Here we see a pressure time plot for a typical DST chart. Note that pressure on the vertical scale increases upward. Time on the horizontal scale increases from left to right. Based on the convention of an individual service company or the design of a particular manufacturer's pressure recorder, the pressure scale or the time scale may be reversed. The manner of recording should not affect the final results, but we have to know which is which. Before the test assembly is run into the hole, the tester loads the chart into the recorder and draws the baseline on the chart using the recorder stylus. This represents 0 psig for the mechanical pressure gauge. The clock is then started, the tool assembled and started in the hole. From what we stated earlier, we recognize this to be a typical DST chart. A to B on the chart represents the buildup in hydrostatic pressure as the test tools are run into the hole. The line is not smooth because of pressure surges which occur as each connection is made, because of tight spots encountered in the open hole, or because of delays required to add cushion or repair surface equipment. After the tools reach the test interval, the surface equipment is connected to the drill pipe. During this time, the hydrostatic pressure stabilizes at point B, pressure surges end, and a value of the initial hydrostatic pressure is recorded at the point where there is a relatively flat pressure value. The packer is then set. The tool is opened, B to C, and the initial flow period takes place from C to D. This period lasts for about 5 to 10 minutes. The initial pressure recorded at point C is usually near atmospheric unless a cushion has been placed in the drill pipe or a highly productive formation is being tested, and it reacts quicker than the recording instruments can record. The tool is then closed and the initial shut-in period, with a duration of 30 to 60 minutes, takes place from D to E. Surface indications of flow cease. The pressure builds up, approaching the static reservoir pressure at point E without the effect of supercharging. The test tool is then opened again from E to F, and the final flow period occurs from F to G. The shape of the buildup will depend upon the properties of the formation and the produced fluids. The duration of this period, as we mentioned earlier, will depend upon whether we are doing an onshore, open hole test, or an offshore cased hole test. At the end of the final flow period, the tool is shut in at point G, and the final buildup period takes place from G to H. The packer is then released at H. The hydrostatic pressure caused by the mud column is again felt by the pressure recorder, and the tool is retrieved from the hole from I to J. The chart is brought to the surface, and the data collected in either chart or digital form is now ready for interpretation.